The starts prices are appointed by the European Commission, and until 2020, as Electronica, in cooperation with BOSA and defy, is issuing these calls. And the grand prize for innovative collaboration between industry or technology and the arts was awarded to our next speaker, Tim Geurtjens. Thanks, Tim, for being here. Thank you. He worked on a project, the 3D printed steel bridge. And I all ask you to go to the exhibition after 1 o'clock, because we show all the projects and of course the winning projects. It's just outside after the cafe area. So you can see what our winners and our participants did. So thanks, Tim, for being here.
Thanks for inviting us, and thanks to the organization to award us with this great Starts Prize, and we're really grateful and honored to be part of this. And well, I want to tell you something about the bridge project that we are doing, that we almost completed actually. A crazy project. We've been working on it for the last 3 years, I think, and right now it's nearing completion, finally, I could say. And when talking about the project, I always think about this guy. I don't know this guy personally. His name is Nikolai Suchajin. He's a Russian entrepreneur, although some say he's a crime lord, local crime lord. I don't know which is true, but what's cool about this guy is that at a certain point, this guy wanted to build his own house. So he went to the municipality, local government, and he applied for a permit for a two-story building, two-story wooden building. And he started building it. And then the building was done, and he looked at his neighbors, and his neighbors had a 3-story building. So he thought, well, you know, I have to top that. So he decided to add an extra level to it. And then he stood on top of his house, and he thought, you know, I kind of like the view, but if I build it just a little bit higher, you know, the view would be even better. In the end, it resulted in this building. This is actually an almost 45-meter high wooden building. At the time of building, it was the highest wooden structure in the world, highest, tallest wooden house in the world. And he built that completely single-handedly. And the reason why I kind of like this example is because, you know, this bridge project for us was a little bit the same. We started somewhere, we started at a certain point, and we didn't know where it was going to take us. You know, so you have a crazy idea. But before you know it, the idea gets crazier and crazier and crazier, and you know, before you know it, you have a building like this. And there's a few more parallels, but I'll get to another parallel later. So we haven't always been bridge builders. We started out as a design company, which we still are, around Joris Laarman, a Dutch designer. And last 15 years, we've been working on a lot of experimental furniture that we sell through a gallery in New York. And we work with new materials, new techniques, and you know, during the last 15 years, we've worked a lot with 3D printing in an ever-increasing amount. And a good example of the use of 3D printing actually is this chair. This is the bone chair. The first one was produced in 2006. It's a very complex shape. I'm not going to tell too much about the design. That could be a lecture in itself. But the way of producing, back then, if we had the opportunity to 3D print it in metal, we would have, but it wasn't possible then. So what we did instead was we printed the mold in a ceramic-like material. And then we casted the aluminium right into it. A bit more recent chair that we produced, where we actually did use metal 3D printing, is this chair. This is printed with a really cool machine. It has a really high level of detail. It can print in aluminium, in stainless steel, many different materials. And it's just a machine has a few downsides for us. One of them is the price. A machine like this will cost you at least €500,000. Oh, you can't see the images? Okay. No problem. Yeah, yeah. Ah, okay. They can see it here, I think. No, no problem.
Yeah, and this is more for you or for the stage. So.
the conference is about error, right? So.
So well done.
Yeah. Yeah, we could do that, yeah. Sorry? For me, it's fine, yeah. Yeah, I mean, if... I think everybody can see everything on this monitors, right? Or not? Oh, no, but, yeah, but I... Okay. Ja, er zit er vastgeschroefd. Ah. Perfect, perfect. This is innovation, right? They should reconsider the starts price, I think. This guy should get it. So, shall I continue? Yep. So I was talking about this machine, the machine that's, that we use to print chairs, which is a really cool machine, but it has a few downsides. One, as I explained, was the price of a machine like this. But the other one is even a bigger downside for us, and that's the building volume. So on the left you see the final chair, and on the right you see in how many pieces we had to actually cut it up in order to fit in a building volume. It's like 6 building volume, and I think it's 16 pieces. And since we didn't find any 3D printing company that would help us develop a 3D printer that's big enough to print full-size furniture, we decided to take matters into our own hands. And we bought an old retired robot from the car industry, and together with 2 students from university, we developed this machine. And it's using a 2-component, really fast curing resin to print lines almost in mid-air. And we kind of like this idea because you use 6 axes rather than the normal 3 axes of a robot, and this allows you to not just print inside a building volume, but also move outside of that building volume and print parts and pieces of virtually unlimited size. Because if you are reaching the end of your building reach, you just move the robot and you can keep on printing. However, this material wasn't really what we wanted. It's a really lightweight, brittle, not appealing material. So we thought, what if we would do the same with metal? What if we take a welding machine and attach that to the robot and start printing with this? And then we can make suddenly we can make full-size steel objects. And brilliant idea, we thought. We were dreaming about early retirement, but unfortunately we found this patent of 1925 of a guy that did actually exactly the same, who used a welding technique to make decorative articles. But luckily he didn't have robots at the time and he didn't have a computer, so there was more than enough for us to develop actually. So, we started working on it, we got better at it, printing simple lines, more complex lines. At a certain point we even, we could print more complex structures. Of course, not everything went right. What you see here actually happened a few times. We set fire to the brooms that were in the workshop, trying to keep a tidy workspace. But that's you need all those things to learn and to get better at what you're doing. And then at a certain point we felt confident enough to print actual pieces with it. So this is also a Joris Laarman piece. It's called the Dragon Bench. We already made, I think, 7 or 8 of those. They're made out of stainless steel, and the cool thing about it is all of those are unique pieces. Which is obviously with 3D printing, you can make, you don't need molds, so you can make one-of-a-kind pieces of everything. But our ambitions rose a bit higher, and we thought, okay, what else can we do with this technique? And by that time, we were on the radar of Autodesk, the software company in the US, and they invited us to San Francisco. And the evening before we had the meeting, we were thinking, okay, we need to present something to those guys that's really going to blow their minds. We need something that we can print that's, that they're really going to like. And literally over a beer in our Airbnb garden, we came to the idea that it really had to become a bridge. Because, if you printing a bridge means you need a mature 3D printing technique. You need good material, strong material. You need a bigger size than just the small iPhone cases that are being printed most of the time. So it totally made sense. We are from Amsterdam. It's known for the bridges and canals, so it totally made sense to make a bridge. But then, then we had the idea. They were enthusiastic about it. We were enthusiastic about it. And instantly we were worried about what we promised. We were like, okay, we're going to make a bridge. Now what? So to kind of get an idea what our first plan was, I made this hand-drawn animation. It took quite some evenings. And our first initial dream was to have the robots walk over the bridge as it was printing it. It turned out to be too complex and too time and money consuming to do so. So I spent a lot of time on this animation, and then I came to the studio to show the animation, and then my colleague Gijs, I think, he came up with this photo, the Sydney Harbour Bridge, really similar in design. And but what I really like is the fact that it's, in a way, it's the same, right? That was also a very analog way of 3D printing, just moving metal to a different location. And on the left, it's really digital, and on the right, it's a really analog way. So, I'm not showing this because I have to from our sponsors, but because it really shows how many companies, how many people you need to do a project like this. And this list is not up to date anymore. It could be like twice as long. There's literally hundreds, maybe even thousands of people worked with us to get this project actually working. And the design also was quite a big challenge. First, we had some wild ideas of how we could print a bridge, because 3D printing allows you to print really complex shapes. So complexity is suddenly a completely different issue than it was before. But we found out that it's not just about what you want to print, but it's also about what you are allowed to do a bridge is more than just something that's printed. It's a construction. There's regulations. There's many more things to it than just shape. So we started thinking about a good design for the bridge. A lot of ideas passed the review. And in the end, we chose this principle. An algorithm is calculating the stress lines within the bridge. And what we did was we translated those stress lines into more dense and more open areas in the bridge. And by that, it's getting the more material and more strength and stiffness on the places where it needs to be. And in the end, that resulted in this design. So if we look at the timeline, we started in 2015. Then we announced that we were going to make the bridge. Right now, we are September 2018. We are just about to finish the bridge. Actually, October 21st, that's the start of the Dutch Design Week in Eindhoven. And we are going to present the bridge there, so it has to be completely done. It's going to take quite a bit of work to get there, but I'm sure it's going to work. And then afterwards, so this is what still needs to be done. We still have to print the swirls that are going to be attached. The bridge deck needs to be attached to it, and then by the time, by October, it'll be completely done. Hopefully, we will be able to place the bridge on the final location in 2019. If, that is, we get a permit for it. Because of course, people have to walk over it. Millions of people every year have to walk over it, so we need a permit for it. And that's also, normally, this is where you apply for the permit, before you start printing. But we didn't have time, we didn't want to wait. We thought, and it's a little bit the same also as this guy, as Nikolai Suchajin, if he would have waited for a permit for this building, it would never have been there. So the only way to get this project done is to start and take the risk of maybe not getting a permit at all. That's still a possibility. Of course, it's not just, we don't leave everything just to chance. We are working on a very good way of certifying the bridge and of making sure that it's strong enough and safe enough. So what we did was we are making a digital twin of the bridge. So we made a scan that's all loaded into a computer algorithm, and we are sensoring up the bridge. So there's tons of sensors going to be on there that monitor every millimeter of movement of the bridge when people walk over it. And by doing so, it's for different reasons, the sensor system. It's also to monitor the traffic in the city of Amsterdam, but it's also for certifying the bridge, for proving that it's going to be strong enough. And what we're also doing is full-scale tests. Coming month, we're going to put 10 tons of weight on the bridge, and then we're going to measure very accurately what the movement of the bridge is. And hopefully, by the end of September, we will be sure that the bridge is going to be strong enough to be placed in Eindhoven. So hopefully, 2019, we will be able to place the bridge on its final location. So that's basically my presentation. The only thing I want to add to it is that, especially a project like this, there's always many reasons not to even start with the project, because why would you print a bridge? It's a very complex thing to do, and it's can be painstaking at times. So there's always, hundreds of reasons not to do it, but we are always looking for the one reason actually to do it. And if you don't get started with it, you will never finish it. So that's basically what our experience with this project is. So, thanks.